Welcome to Study Loop.
For part A of the given problem for Mn55, the mass density ρm is given by m divided by v. Substituting value 0.055 kilograms per mole divided by the volume, which is a 4 pi r cube. So r we have is r naught 1.2 times 10 to the power minus 15 meter, r naught times a, which is 55 for this case, 1 over 3 whole 3 times the Avogadro's number, which is 6.02 times 10 to the power 23 per mole. This gives us the mass density of 2.3 times 10 to the power 17 kg per meter cubed. For a part B of the problem, we use the same procedure for a BI 209. We will only replace the value that we wrote here, 55, we will replace here, for this case 209, and do exactly the same thing, for only the m will change, which is 0.209 kg. So substituting these values, kg per mole, substituting these values in the equation and doing the same thing, we obtained the mass density to be ρm to be 2.3 times 10 to the power 17 kg per meter cube. For part C, since we see volume is proportional to r cube, and this is proportional to r naught a 1 over 3 whole 3, so 3 cancels out, we are left with this is proportional to a, and we expect mass density to be proportional to a divided by v, which is proportional to a over a, so which is constant. This is for all nuclides. Part D, in this step we find the charge density. So charge density will be rho q. This is a total charge divided by a volume. Total charge we obtain plus z 25 is z times the charge on each particle, which is 1.6 times 10 to the power minus 19 coulomb, divided by volume 4 pi over 3 times 1.2 times 10 to the power minus 15 meters times 55 1 over 3 whole 3, and this gives us a charge density of 1 times 10 to the power 25 coulomb per meter cube. In part E, we do the same steps for the z value here. Only the z value here will be 83, and for a v we write a to be, so a will be, our a will be this is volume 4 pi 3 r naught a 1 over 3 whole cube, when a will be here 209. Substituting those values, we obtained rho q to be 8.8 times 10 to the power 24 coulombs per meter cube. For a part F, we note that the charge density rho of q is proportional to z over v, and this is proportional to z over a, which should gradually decrease since a is greater than a2 of z for a large, for 2z for large nuclides.